In alpha decay process, the daughter nucleus thorium and alpha particle, both of them will be moving in the opposite direction and they will have kinetic energy, and here the alpha particle will have 98% of the kinetic energy of the both, and the thorium will have just 2% of the total kinetic energy of the both. Are you clear? So we are going to prove that 98% of kinetic energy is possessed by alpha and 2% of kinetic energy is possessed by thorium. So this is the thing to be proved. Already by using law of conservation of momentum, in the previous video we have derived the formula for velocity of the alpha particle. Velocity of alpha particle can be obtained by this simple formula, that is mass of thorium into velocity of thorium divided by mass of alpha particle. So this expression to be utilized for further derivation. In the first video, we have derived the expression for Q. So what is Q? Disintegration energy. The disintegration energy which is obtained in this process is converted into the kinetic energy of the thorium and kinetic energy of the alpha particle. So the disintegration energy was already calculated, its value is 5.41 million electron volt. Okay, so how to start the derivation? Look at here. So kinetic energy of alpha particle divided by kinetic energy of thorium. So its ratio to be calculated. Kinetic energy of alpha particle can be written as half m alpha v alpha square. This is a fundamental formula, divided by half m thorium, mass of thorium, into velocity of thorium square. Both can be written. Here half can be cancelled. Are you clear? So in the next step, what should be written? The next step, here m alpha can be written, and instead of v alpha, we can substitute mass of thorium and the velocity of thorium whole divided by which one? Mass of alpha. The entire thing must be squared, whole divided by mass of thorium, and velocity of thorium can be written and it can be squared. So everything is written, is clear, and V alpha is substituted. So what is the next step? This one could be expanded further. Are you clear? This m alpha here it must be squared. So m alpha mass of thorium square, velocity of thorium square divided by mass of alpha square whole divided by, this part must be written, this is the remaining thing, mass of thorium, velocity of thorium square can be written. So here, which one can be cancelled? One mass of alpha, and here that square can be cancelled. So here remaining thing is m alpha, and then here what is the remaining thing? Velocity of thorium square, velocity of thorium square can be cancelled, both of them can be cancelled, and then mass of thorium square is there, here mass of thorium is there, mass of thorium can be cancelled here, remaining is mass of thorium. This is the only factor that is remaining. So ultimately you will be getting mass of thorium divided by mass of alpha. Mass of thorium divided by mass of alpha particle you will get. So the kinetic energy of alpha particle to the kinetic energy of thorium is equivalent to mass of thorium divided by mass of alpha particle. So this simple derivation must be derived first. Okay. Here, after deriving this ratio, the final expression mass of thorium divided by mass of alpha must be substituted in the RHS side. So the next thing is, we know the mass of the thorium. From this expression, in the superscript, which one is appearing there? 228 is there. The 228 can be approximately written here. 228 is the mass of the thorium. Are you clear? Mass of alpha particle is nothing but what is this? 4. Are you clear? 228 divided by 4 will be equivalent to 57. Are you clear? So what it shows here, the kinetic energy of alpha is how many times of kinetic energy of thorium? Kinetic energy of alpha is 57 times of the kinetic energy of thorium. So this is the general value that is obtained here. Are you clear? Now In the next step, we can write it as, here this one can be written as kinetic energy of alpha is equal to 57 times of kinetic energy of thorium. Are you clear? So in this step, after cross multiplication, we can write. Are you clear? This is a very important step. Are you clear? Now, already I have written the disintegration energy which is released in the process, that is utilized for the kinetic energy of thorium and kinetic energy of alpha. That Q value was already calculated. So take this expression here, kinetic energy of which one? Thorium, and kinetic energy of alpha particle, that is nothing but what is this? Disintegration energy, which is equal to 5.41 million electron volt. Just for understanding purpose, I have written the Q in between. Can you understand? Now we know very well that kinetic energy of alpha particle is how many times of kinetic energy of thorium? 57 times. So here we can write kinetic energy of alpha particle is clear. This step to be written. Are you clear? This step can be written here again. Kinetic energy of thorium plus kinetic energy of alpha particle is how many times? 57 times of kinetic energy of thorium. So in that format we can write. Are you clear? So that is equal to how much? 5.41 million electron volt. So like this we can write. Okay. Here this one can be written as 1 kinetic energy of thorium, 1 times of kinetic energy of thorium plus 57 times of kinetic energy of thorium is equal to 5.41. If you add both, you will get 58 Ke thorium can be written. After adding, since both are similar in their factor, we can add them now. So you will get 58 Ke thorium, which is equal to how much? 5.41 million electron volt. Like this we can write. After adding, quickly this one you will get, and this one to be substituted here. Now we are able to calculate the kinetic energy of thorium now. How to calculate the kinetic energy of thorium? I will write it here. Kinetic energy of thorium is equal to 5.41 million electron volt whole divided by how much? 58. So finally you will be getting kinetic energy of thorium will be equal to, after calculating this factor, you will get 0.093 million electron volt. So this is the kinetic energy of the thorium. How to calculate the kinetic energy of alpha particle? Very simple one. So here already we have calculated in this formula. Are you clear? In this formula you have to substitute. Because kinetic energy of thorium is known now. Substitute this value here and automatically you will get kinetic energy of alpha. So kinetic energy of alpha is equal to 57 times of kinetic energy of thorium. Substitute now. 57 into 0.093 million electron volt. So after multiplication, the kinetic energy of alpha particle will be, calculate now, you will get 5.301 million electron volt you will get. So this is the kinetic energy of thorium, this is the kinetic energy of alpha particle, both are found out. Are you clear? Now we have to prove that out of the total energy, out of the total disintegration energy, kinetic energy, clear, 98% of kinetic energy is possessed by alpha particle, just 2% of total energy, kinetic energy is possessed by whom? The thorium. That should be proved now. Okay. Now we have calculated both kinetic energy of thorium and alpha particle. Both were just few minutes back, both of them were calculated. Now we have to show them, we have to show both the two things in terms of percentage. How to do this? Kinetic energy of thorium is equal to that is to be represented in terms of percentage. 0.093 million electron volt whole divided by, here if you add both you will get 5.41. So 5.41 million electron volt. So that is the total energy possessed by both. So this is the energy possessed by which one? Thorium. This is the total energy possessed by both. After calculation you will get, is it clear? This is to be multiplied with 100. Only then you will get the value in terms of percentage. So if you calculate everything, you will get how much? 2%. Are you clear? 2% of the total kinetic energy is possessed by whom? Thorium. Are you clear? Now let's go to the alpha particle. Kinetic energy of alpha, that is to be given in terms of percentage. 5 point, this is a kinetic energy possessed by alpha, 5.301 million electron volt divided by total kinetic energy is how much? 5.41 million electron volt. To convert the value in terms of percentage, that one must be multiplied by 100. So finally you will be getting 98%. So this 98% of whom? This is a 98% of the total kinetic energy, or you can call it as disintegration energy. Are you clear? So which one will be moving with greater speed? The alpha particle, that one will be moving with greater speed with greater kinetic energy, since it is possessing lesser mass, and the thorium is clear, big, so big. Are you clear? Its mass is heavier, therefore its kinetic energy is less, its velocity is also less. So we have proved the entire thing by solving the problem. Okay, thank you.